Hi everyone, welcome to all for this channel. Dear friends, today we are going to discuss about electric field due to the spherical charged cell using Gauss law. This is the fourth application of Gauss law. In the first application of Gauss law, I have told you in the 5-mark part, in the 5-mark section, they may ask the question, state Gauss law and deduce an expression for the electric field due to the infinite long charged wire. Are you clear? Right. Otherwise, in general, they may ask in the 5-mark part, state Gauss law and deduce the electric field due to the long charged wire and plane charged sheet. Otherwise, they can ask any two applications of Gauss law. Okay? Right. So, before going to enter this video, dear friends, if you are watching this video first time, if you are watching this channel first time, please subscribe this channel. And after watching this video, if you really enjoyed, you can like this video and you can share this video to your friends and also your relatives. Okay? Only after subscription of our channel, you can receive the notifications of all video when we are uploading. Okay? Right. Now, let us move to the topic. What is the topic today we are going to discuss? Electric field due to spherical charged cell using Gauss law. Okay, right. So in this video, we are going to see entirely different from the first three parts. Okay, right. Now, in this video, we are considering the spherical charge or spherical charged cell or charged spherical cell. In the previous three cases, we have discussed about the uniform linear charge density lambda is equal to Q by L. This is the first application. In the second and third application, we have discussed about uniform surface charge density, that is sigma is equal to Q by A. Now, in this fourth application of Gauss law, it is entirely different from these two charge densities. Okay, what is the different here? Here we assume that Q is the charge which is uniformly spread on the surface. We are taking the sphere of radius R. Now we are taking the sphere which has the radius capital R. Now Q is the charge which is uniformly spreaded. You can see this image. You can notice that there are plus sign, it is uniformly spreaded on the surface. Okay, that I wrote here. Let Q be the charge uniformly spreaded over the surface. Okay, right. At the point P, now we are taking the point P on the surface of the sphere. Okay, so what is the distance between the center and the point? That is nothing but capital R. Now, in this point P, we are going to calculate what is the amount of electric flux. So, what is the formula for electric flux? Electric flux, it is given by pi E is equal to closed integral E dot ds cos theta. Okay, what is theta? Theta is nothing but cosine of the angle between the electric field and the area vector. Okay, right. If we consider the Gaussian surface on the surface of the sphere, we can see that here I wrote clearly the direction of electric field. Because of the positive charge, the electric field is always acting radially outwards in all the directions. So, wherever we are taking the point on the surface, the electric field is always directly outwards. Then at this point on the surface of the sphere, anywhere, the normal line, if we are drawing, it is also just parallel to the direction of electric field. Okay, so only one thing we have to remember here, the angle between the electric field and the area vector is always equal to 0 all the points on the surface of the charged sphere. Okay, if theta value is equal to 0, then cos 0 is equal to what? 1. Then what will be the final flux formula? It is given by integral E dot ds. E is nothing but electric field, but we are going to calculate. What is ds? It is depending upon the size of the body, geometry shape. Here we are considering the sphere, so area of the sphere is given by 4 pi r square. Are you clear? Right. Now, what is the total flux? We can calculate now. The total flux is given by pi net is equal to, that is nothing but net electric flux. Pi net is equal to E dot ds. It is in the vector form. Okay. So, magnitude of electric flux is given by Q net is equal to E dot ds cos theta. What is cos theta? Cos 0. Cos 0 is equal to what? 1. So that the final electric flux, it will be given by the formula integral E dot ds, because cos 0 is equal to what? 1. Where E is nothing but the electric field that we are going to calculate. It need not to be integrated. So it is taken out from the integral. Then only integral ds will be there. What is integral ds? It is depending upon the geometry, shape and size. What is the geometry shape we considered here? That is sphere. So the area of the sphere, it is given by the formula 4 pi r square. So integral ds, it can be given by 4 pi r square. So that I have given in the equation number 1, Q net is equal to E into 4 pi r square. Pi net, the flux is equal to E into 4 pi r square. Now, the total flux by using the Gauss law, pi is equal to net charge by epsilon naught. That is, we are using in the next equation number 2. So that I wrote here, by applying the Gauss law, pi net, the net flux is equal to net charge divided by epsilon naught. Now, we are using the formula number 2. Equation number 2 in the equation number 1. Otherwise, we can write on comparing the equation number 1 and 2. In left hand side, we can replace net flux by net charge divided by epsilon naught, and right hand side as it is, which is given by E into 4 pi r square. Now, what is our aim? We have to find out the value of electric field. So 4 pi r square is not needed. It can be brought to the left hand side. Okay. So in the next step, what we have done, the 4 pi r square, it is brought into other side. Okay. Then we can write E is equal to 1 by 4 pi epsilon naught into Q by r square. Dear students, now you have to remember, in somewhere we have seen the formula E is equal to 1 by 4 pi epsilon naught into Q by r square. Where we have seen? Anybody can remember? That is nothing but electric field due to a point charge. Okay. So one thing you have to understand, that electric field due to the spherical charge cell is same as that of the electric field due to the spherical cell. Then one more concept we have to remember, that the point charge is considered as a sphere. Okay, are you clear? Right. So from this equation we can understand that the net electric field due to the spherical charged cell on the surface is given by 1 by 4 pi epsilon naught into Q by r square. In this diagram we have taken as capital R, so we can write capital R square. Okay, you can change this. Electric field is equal to 1 by 4 pi epsilon naught into Q by r square. In vector form, it can be multiplied with a unit vector n cap. E vector is equal to 1 by 4 pi epsilon naught into Q by r square into n cap. Okay, this is the electric field due to the spherical charged cell. Okay, then one more point I wrote here. for your reference. This is the electric field at the point P on the surface due to the charged spherical shell is similar to that of the electric field due to the point charge. Already we have discussed. The same I wrote here. The next case is nothing but in this spherical shell, we are considering the surface which is outside the cell. Outside the surface, we are considering one more surface. That is the yellow color is marked here. That is the outer surface. Now the radius value, it will be increased. Now the new radius is considered as small r. It is represented here. The first sentence also I wrote. Let us take the point P dash outside of the sphere of radius small r from the center. Okay, right. Then in the next point you can see that here also the direction of electric field and area vector are same direction as it is in the surface. So in the first case we have seen that if we consider any point on the surface of sphere radius r, the direction of electric field and normal drawn to the point anywhere on the surface is always parallel. Here also the direction of electric field and normal line drawn to the point on the surface of the sphere, outside the sphere, they are parallel to each other, so that the angle value is always equal to 0. Then cos 0 is equal to what? 1. Okay. But only one thing, the radius value, instead of capital R, we have chosen the value small r. Remaining on all same, so that we can see here in the third point, but in this case r is equal to capital R is equal to small r, so that the electric field at point outside the spherical shell is given by the formula E is equal to 1 by 4 pi epsilon naught into Q by small r square, where small r is equal to capital R. Just we are replacing. Okay. Why? Because in the previous case, already I told you to write the correction. Here, instead of small r square, you have to change as capital R square. Why? Because we have chosen the radius capital R, so that here also we have to write as capital R only. Okay, right. But in the next case, outside the surface, the radius is taken as small r, so that in the final equation, while calculating the electric field, E is equal to 1 by 4 pi epsilon naught into Q by small r square. Are you clear? Right. Now the third case of this fourth application is nothing but electric field inside this spherical shell. Here you can see that there are three spherical shapes drawn here. First one is inner surface, which is represented by the radius r dash in green color. Then next surface is nothing but represented in orange color, which has the radius capital R. And third sphere is nothing but small r. Okay, right. So the first sphere is nothing but r dash. Then second, this is the actual sphere. Its radius is nothing but capital R. The outer surface is represented by small r. Okay, so you have to remember the diagram also. So let us consider the point P makes a inner surface. So we are taking the point here inside the surface. Are you clear? You have to remember that the point is considered here. So this is the on the surface, this is outer surface. Now we are taking the point inside the surface. Its radius is considered as r dash. So in the first sphere, which has the radius capital R, second sphere is nothing but outer surface, which is nothing but small r. The third sphere, which is inside the actual sphere, is nothing but very small, which has the radius r dash. Now what will be the electric field inside the sphere? Okay, we know that the inside the spherical shell there is no net charge. If there is no net charge means we can write Q is equal to what? 0. Then what will be the electric field? Already we know the formula for electric field due to the spherical shell, okay, which is given by E is equal to 1 by 4 pi epsilon naught into Q net. Here we should not write epsilon naught. Please strike out this. Okay, here also you should not write. I am so sorry. Please strike out this. So 1 by 4 pi epsilon naught into q net by r dash square. What is the q net? Already we defined the net charge is equal to what? 0. If net charge is equal to 0 means in numerator it will be 0. 0 by anything is equal to what? 0. So that the net electric field inside the spherical cell, it will be equal to 0. Dear students, please remember this. There should be no epsilon naught because already we wrote epsilon naught. Okay, so 1 by 4 pi epsilon naught into q net by r dash square. Here 1 by 4 pi epsilon naught into 0 divided by r dash square. E net is equal to what? 0. Why? Because the net electric charge inside the sphere is equal to 0. The electric charges are only spread on the surface of the sphere. So that we should remember inside the spherical cell net charge is equal to 0. Now we can come to the conclusion. Okay, as the distance increases, the electric field it will be decreased because E is inversely proportional to square of the distance. Okay, so in this case what you have to remember, if it is a spherical cell means the electric field is 1 by 4 pi epsilon naught into q divided by r square, which is equal to the electric field produced by the point charge. Okay, depending upon the distance, depending upon the point we are choosing from the sphere, whether on the surface of the sphere or outside the surface of the sphere or inside the surface of the sphere, the magnitude of electric field it will be changed. How it will be changed? E is inversely proportional to the square of the distance. So that from the surface or on the surface, the electric field value it will be more. When the distance is increased from the surface of the sphere, electric field value it will be decreased. Why? Because E is inversely proportional to the square of the distance between them. But one thing we have to understand, inside the sphere there is no net charge present. So if there is no net charge means no flux will be there. If no flux is there means then electric field value it is also equal to 0. Okay, so these are the important 3 cases in the 4th applications of Gauss law. Okay, right. Just now we can discuss the 4 applications of Gauss law here, just for remembrance only. For the first case, due to infinite long state conductor, E is given by the formula E is equal to what? Sigma by 2 pi epsilon naught r. This is first. Then for plane sheet charge, E is equal to sigma by 2 epsilon naught. Then third case, E is equal to sigma by epsilon naught. Then fourth is E is equal to K into Q divided by R square. What is K? K is equal to 1 by 4 pi epsilon naught into Q by R square. What are the other things we can remember from these 4 concepts? Here E is inversely proportional to R. Here E is directly proportional to sigma. Here E is directly proportional to sigma. Here E is inversely proportional to the square of the distance. Okay, these are the important concepts that we have to understand from these applications of Gauss law. Are you clear? Right. I hope you all can easily attend this question if they are asking even in 1 mark, 2 mark, 3 mark, wherever it may be. Definitely you will get more marks and you will get maximum marks. Okay, so dear friends, if you have enjoyed this video, kindly like this video and share this video to your friends also. Still, if you are not subscribing our channel, please subscribe our channel, then you will get all the videos what we are uploading every day. Okay, thanks for watching. God bless you.